So thanks for coming to our first event of the year. So by the way, for those of us who doesn't know who we are, so we are Statistical Society of Australia, particularly we're the branch at in Victoria and Tasmania. And so pretty much we are like the statistics body here in Australia. And in this branch, we have the habit of organizing an event every month of various types. Sometimes we have some early statisticians gathering, networking events. But today, I'm very excited to be able to invite Simine Vazire, who is a full professor here, to give us a talk on replicability, reproducibility, and how to do meta and how to do meta science in general. So before we start, welcome. So first of all, I have to acknowledge the country. So we pay respect to the traditional and original owners of this land, the Mawinina people, to pay respect to those who have passed before us, and to acknowledge today's Tasmanian Aboriginal people who are the custodian of this land. We extend our welcome also to the traditional owners of the lands from which people in our live stream are joining. So this is actually the council that is going to end very soon in a month. This is like the council for 2024, and we will have a new council very soon in a month. So I myself am a membership officer, and so this is our council for the year. And so this is, you can follow us, our society, the activities of our society on social media. So we have also designed a T-shirt, a pretty interesting T-shirt by our previous president, Ben Harrop, that you can buy. So you can, we do encourage, particularly, we encourage everyone to join as a member, because there are a lot of perks and stuff. But we especially encourage the student to join, because it is really literally just $20. Like sometimes we give out scholarship for students to attend conferences, and you actually make money off of that $20 you're paying per year. And there are a host of other benefits that you can explore with our society, and then you can go to this link. So as I said, like this really is the wrapping of our current council. And actually, in less than a month's time, at the end of March, we're going to have our annual general meeting in which we will elect our new council for the next year, for 2025. And right after our AGM, we'll also have a talk by Professor Jessica Kessa at Monash, who actually has always been very active with SSA Society, and she's going to tell us something about randomized trial. But today's event is about Simine Vazire. So just a brief introduction. Simine Vazire is a professor in the Melbourne School of Psychological Sciences here at University of Melbourne, and her research examines the individual and institutional practices and norms in science, and the degree to which these norms encourage or impede scientific self-corrections. She co-founded the Society for the Improvement of Psychological Science, and she's the editor-in-chief of Psychological Science. So we welcome Simine, and let's hear it for her first. And she's going to tell us about where are the self-correcting mechanisms in science. So let's welcome Simine.
Thank you.
Yeah. Okay.
Thanks. Thanks so much, Dennis. And thanks everyone for being here. I'm excited to talk to you today. I'll tell you a little bit about my background and why I'm speaking to a statistical society, even though I'm not at all a statistician. So my field is psychology, and specifically social psychology, which you might have heard went through a replication crisis, is still going through a replication crisis. And a lot of that had to do with our use of statistics. And so what I'm going to do today is kind of explain to you how we've been using statistics a little bit and how it got us in trouble. And I think some of this will be very basic and obvious to you all, but I think it's an interesting case study in how a scientific discipline can go wrong. And it was kind of a stress test of the self-correction mechanisms in science. And I think what we learned in social psychology is a warning for other disciplines. And since kind of getting involved in the reform movement in psychology, I've been approached by people in many other disciplines, mostly biomedical and social science disciplines. But also I gave a talk at UQ in the physics department last year about like, how would you know if your field was in a replication crisis? There's starting to be some concerns among some people in physics about some of the same signs, kind of institutional practices, journal practices, et cetera, that we saw in the early days of the replication crisis in psychology. There are also a lot of differences, but some similarities. So one critical thing about psychology is that we rely extremely heavily on null hypothesis significance testing. There's very, very little deviation from that statistical approach. There's now a little bit more Bayesian statistics being used in psychology, but it's still very much the minority. And there's a lot of kind of rote practices in how we use NHST in psychology. So I want to start by acknowledging my collaborators. They're not responsible for any mistakes or anything wrong in this presentation, and certainly none of the very bad opinions that I'll share, but they were really influential in my thinking. So you've probably heard of the replication crisis. It started in medicine before it started in psychology, but I think it got more traction quicker in psychology. So it got a lot of media attention when psychology started to have problems with replicability and reproducibility. But it's not just psychology. So there were other disciplines that started doing replications. It's very strange to try to be looking at you all. No. Anyway. It included other social scientists, economics, political science, and many biomedical sciences, as I mentioned. Cancer biology had a really bad case when they attempted to do some replications. And so what we were learning was that, we all know that science is messy, that individual results are far from perfect and far from definitive. But what we found was that what gets published is a lot neater and tidier and too good to be true. And so when you go and try to replicate what's in the published literature and you don't filter on significance, you don't have all these biases that come in, you get a much messier result. And this is true across many disciplines. Things like publication bias, which I'll talk a little bit more about, contribute to this. But there's some signs that maybe it's worse in psychology. So there might be some reason to think psychology is especially vulnerable to some of these problems, but it's not that different in other sciences. So this was a graph from a news story by Ed Yong, where he looked at the proportion, sorry, it's too blurry to read, but I'll just tell you what it shows. It shows the proportion of positive or significant results in the published literature in different disciplines. And the x-axis goes from 50% to 90+%. The green bar at the bottom is psychology and psychiatry at more than 90%. So in psychology, more than 90% of published articles claim to find support for the research hypothesis, p less than 0.05. The other fields near there are materials science, pharmacology, clinical medicine, biology and biochemistry, economics and business. Those are all around 85 to 90%. The ones at the top, so where it's closer to 70%, are space sciences, geosciences, environment and ecology. And physics is a bit further down at 80. Actually, yeah, it already gets to over 80% by then. It's unclear what the right proportion should be, but over 90% is completely unrealistic, right? For that to be accurate, it would mean that our research hypothesis would have to be true 100% of the time, and we would need 90+% statistical power, or it's close to 100% statistical power, and our research hypothesis being true 90+% of the time. Those things are not reasonable. It's not plausible at all. And so this is another analysis of the published literature in psychology and biology, looking at what proportion of published findings fail to find support for the research hypothesis, and is 5 to 20%, closer to 5% in psychology. So again, finding the same kind of thing. And so this is already reason enough to suspect that what's in the published literature does not reflect an accurate, unbiased view of what the empirical evidence would show. And in psychology, we've been aware of some, practices that might be contributing to this kind of exaggeration and so on. In the late 1990s, there was a term called harking that was coined by a social psychologist, which stands for hypothesizing after the results are known. So you run your study, you analyze the data, you find something interesting, and then you write up the paper as if that's what you were looking for the whole time. So you kind of move the target to be wherever you found a significant result. For a long time, many of us were literally teaching our graduate students. I was teaching graduate students that this is what you're supposed to do. There's a classic paper on how to write a psychology article by Daryl Bem that was considered standard curriculum for PhD students in psychology that explicitly said, nobody wants to read the paper about how you didn't find what you were looking for. You should write up the paper about the most interesting result and set it in the best possible setting and frame it as for the reader to lead up to it as if, basically saying as if you had predicted it. And in psychology, we kind of all knew that this was common practice. We knew that when you read as predicted, blah, 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 we should take that with a grain of salt. But if that's all it was, maybe it wouldn't be so bad. But it turns out that there are a lot of things besides harking that are contributing to this kind of over exaggeration of results and then leading to failures to replicate. So another one I'm sure you've heard of is p-hacking. So this term was coined by some psychologists during the replication crisis. And p-hacking, as the term implies, is basically analyzing the data in order to get a p-value below the alpha. And I've been to now conferences where people talk about these problems in other fields. In spinal cord injury research, they call it testing to a foregone conclusion, which is a nice phrase, I think. And the tricky thing about p-hacking is that it sounds like the kind of thing that someone sits there and is like, ooh, I'm going to p-hack now. But of course, that's not what it looks like. And when we started realizing how easy it is to p-hack and looking for it, we realized we were doing it without knowing all the time. So here's just a simple example from a colleague's slide about 6 ways to p-hack in psychology. So you could collect data and peek at your data and stop collecting data when p is less than 0.05. Inflates type 1 error rate dramatically if you do that. Another one would be to collect multiple outcome measures, but report only the significant ones, so outcome switching. Collect and analyze many conditions. So maybe you have a manipulation, you have different levels of that manipulation. You quietly drop ones that don't show an effect. You selectively use covariates to get your p-value to be significant. You exclude participants, or you transform data. And again, these sound kind of sinister, but it's so easy to justify these things. And I actually had a paper I was writing up from my dissertation. So in like 2008 or 9, I was writing up data for my dissertation and I got distracted and didn't ever submit the paper. And it's this like frozen in time relic where I had all these outcome measures that were not normally distributed and I didn't know how to handle them. So I thought, I know what I'll do. I'll try different transformations and whichever ones make the effect pop out, those must be the right transformations, right? And I'm smart enough that I should have known how stupid and bad that logic is, but that's what so many of us were doing. And when you see the transformation that works, then you can realize it's so easy to convince yourself, oh yeah, of course that makes sense. And same thing with excluding participants or using covariates. There are often like theoretical or just common sense reasons that you can come up with after the fact for why those are obviously the right covariates. Or, oh yeah, of course, we should have excluded the participants we ran that week because that was the week that the election happened, or that was the week that whatever. It's very, very easy to come up with a reason that might actually be valid and that you can convince yourself is valid. And so the authors who came up with the term p-hacking, I think, had a really nice description of it in this Wired article that Christia Schwanden wrote, where she interviewed them. Joe Simmons was interviewed, and he said he and his colleagues have been very explicit that p-hacking isn't necessarily a nefarious endeavor, but rather a human one, and one that they themselves had been guilty of. At its core, p-hacking is really about confirmation bias, the human tendency to seek and preferentially find evidence that confirms what we'd like to believe, while turning a blind eye to things that might contradict our preferred truths. The hacking part makes it sound like some sort of immoral behavior, and that's not helpful, Simmons says. People in power don't understand the inevitability of p-hacking in the absence of safeguards against it. They think p-hacking is something that evil people do, and since we're not evil, we don't have to worry about it. But Simmons says that p-hacking is a human default. It's something that every single person will do, that I continue to do when I don't pre-register my studies. Without safeguards in place, he notes it's almost impossible to avoid. And this has been my experience as a researcher too, that if I don't write down ahead of time what my plan is for how I'll collect and analyze my data, how I'll decide how to exclude participants or what covariates to use or which conditions to compare, it's impossible not to engage in motivated reasoning. And some of that makes sense, right? You should sometimes change your plan after you see the data. Sometimes there is something that goes wrong. Sometimes there was a week where the data collection was terrible because some world event happened that messed with, the phenomenon that you're studying. That does happen, but you should be aware that you're at risk now of motivated reasoning and of inflating error rates. So by writing down the plan ahead of time, it's not so much that we're absolutely no matter what going to stick to that plan, but that we're going to be aware and disclose to readers that there's now a heightened risk of bias if we deviate from that plan. Okay, so p-hacking is another one. The other contributors, I'm sure you've heard of, are file drawering. So maybe you're honest and you do a single analysis and you don't get a significant result, but then you don't publish it. So it doesn't end up in the literature. And parallel to that is publication bias. So this is journals not wanting to publish non-significant results. So all of these things kind of combine to create this perfect storm of an extremely biased literature. And when I became a journal editor, so now I've been a journal editor for 15 years, edited a handful of journals. And it became really clear to me how complicit we journal editors are in all of this. Even when you're trying not to create incentives for authors to p-hack or selectively report, it's very, very hard not to do that. And so it's this vicious cycle where researchers engage in motivated reasoning, not because they're evil, just because it's very, very hard not to. And also they are quite, researchers often are passionate about the subject they're studying. In psychology, we're often studying things like how to reduce prejudice or how to improve leadership styles or things that, have societal impact and we're trying to help people. And that can, I think, amplify the motivated reasoning. We really want to find a solution to these problems. Journals want to select the prettiest results. They explicitly have the goal of increasing their impact factor, or it's a slightly more noble, more scientific goal, like they want to publish stuff that the community is going to find interesting and valuable and want to build on. And so bad research practices are rewarded, these kinds of things that exaggerate results, and it leads to this vicious cycle. So what that led to in psychology was a replication crisis. So there have been a number now of large-scale studies that have tried to systematically replicate, and I'm going to use replication to mean collect new data to test the same hypothesis, trying to follow the original methods as much as possible. These projects trying to replicate original studies in psychology and more broadly in the social sciences have led to a pretty significant crisis because the results are quite bleak. So I'm just going to summarize. Don't worry about the details here. I'll give you a summary across the social sciences of these large-scale replication projects that have been done, mostly in psychology, mostly on a very highly cited or published in top journals studies. And the overall replication rate is roughly 46%. That estimate is way more precise than you should take it with a big confidence interval around it. There's a lot of debate about could many of these be false negatives or other things like that. But even if you take a pretty big confidence interval around it, this is so far below what these journals advertise, right? None of these journals are saying, hey, it's a coin flip whether or not this is even true in the narrowest sense of true. Forget about the broader sense of is it generalizable, are we interpreting it correctly, et cetera. Is it even a signal and not noise? It's a coin flip, or maybe slightly better if you want to be generous. And it wasn't just replicability. When we started kind of looking at our research practices and our published literature, we found other problems too. So another standard besides replicability is reproducibility, which is, I think, a lower bar. It's saying, I'm not going to collect new data. I'm just going to reanalyze your data and see if I can get your effect. Like, there's no reason why I shouldn't be able to do that. And Tom Hardwick, who's done a lot of this kind of meta research, doing audits of the literature, he did an audit of articles published in a journal that was really a leader in transparency. It was a journal that started requiring authors to post their data publicly well before many other journals were doing it. It's still very rare. Very few journals require it in psychology. But this journal started requiring it. And so Tom Hardwick went in and selected a handful of manuscripts or articles published in this journal and tried to reproduce all the statistical results in about 30 or so articles in that journal, and found that for about a third of them, they could reproduce the results without asking the authors for more help. For roughly another third, they could do it, but only after asking the authors to explain some stuff that wasn't clear from the published paper and the data set. And in more than a third, they weren't able to reproduce every single result, even with the author's assistance. Now, this is a fairly strict standard where they have to be able to reproduce every single statistical result in the paper. So some of these failures to reproduce might not be of the central result. But again, this is like a journal where they were requiring much more transparency. Authors were selecting into publishing in this journal with this really high bar. So probably if we tried to reproduce results in a typical journal in psychology, it would be a lot worse than this, because we would stumble at the first step, which is just getting the data. There's a lot of research showing that even though authors who publish in psychology journals agree in principle to share data on request, they don't actually respond to requests to share data. So we realize that we have a big problem in psychology, that our results don't even pass these very low bars of like, is there a signal here? Can we replicate the signal? Can we at least confirm that it was there in the original data? And again, that's not even getting to bigger questions of like, is it a valid conclusion? Are the causal inferences valid? Are the generalizations valid? And so on. And there was another sign that things were bad, which was when we go back to this estimate of the published literature where only about 5% of psychology articles find a non-significant effect. There was a new kind of article introduced that was aiming to reduce bias. And so we wanted to see what would happen if we tried to close the door to a lot of these biases like p-hacking and publication bias and so on. So this new article type gave us a way to estimate what would happen if we did that. So this article type is called registered reports. You might have heard of it. It's fairly rare still in psychology, but it's picking up, more and more journals are offering it, which is where authors submit their paper before they collect the data. So they write up their introduction, the proposed methods, the proposed analyses, and they submit to a journal for peer review at that point. And the journal sends it out for review. And if they decide that they think there's something, it's a good study, worth this important question in a well-designed study, they give the authors in principle acceptance. They say, as long as you do what you said you were going to do and you pass some quality checks, we'll publish the results regardless of how they come out. So this removes any incentive for authors to p-hack, not all incentives, because authors still are attached to their hypotheses and want to find positive results, but it reduces some incentive for authors to p-hack, and it reduces a lot of opportunity for authors to p-hack because they're being held accountable. They have a plan that they agreed to, and if they deviate from it without a good reason, the journal should notice and say, no, you can't do that. So then there's a light review after the results come in that's just checking, did you do what you said you were going to do? Did you pass the quality checks? And are your conclusions calibrated to the evidence? But the journal is committed to publishing it. It can't reject at that point, in principle, if the authors did what was agreed. So we can look at this literature. It's a relatively small literature, so this is a rough estimate with not a lot of precision. But in the first 100 or so articles that use this model, we can look at what proportion of those articles did the results support the research hypothesis versus it was a null result. And here we find it's 55% of studies, the key result is a null result. And when we kind of close the door to a lot of these biases. Now, causal inference here is tricky. Maybe researchers are submitting more ambitious studies where the research hypothesis is less likely to be true. There's some more meta-research now happening trying to evaluate whether that's the case. Okay, so then we can look at just replication studies that use this, where we know in the original literature the result was significant. Then we do a replication using this model where we reduce the opportunities for bias, and we find a similar proportion. 2/3 of the studies are null results. So again, this is now holding constant what the research hypothesis is in the original literature and in the replication study. What's interesting to me about these estimates is it's really, really similar to the proportion of replications that fail in psychology. So in these replication projects, about 54% of replications failed. When we close the door to bias and we do publication this way, again, about 55% of research fails to support the research hypothesis. So there's a lot of reasons for concern that what we're doing in psychology, our normal research practices, are creating very high rates of type 1 error, and that journals are contributing to this and rewarding those kinds of practices and publishing things that are too good to be true. So then the question is, okay, so this is a situation where the self-correcting mechanisms of science are supposed to kick in, right? We're supposed to realize we did something wrong and fix it. And so I used to teach research methods to undergraduates. I would have 500 undergraduates in a room. They were in their first year. And I would be teaching them about the scientific method and so on. And as the replication crisis started happening in psychology, I had a crisis of confidence. I couldn't stand up there and teach them that the scientific method is, reliable and science is self-correcting and so on. And so I started doing a lot of self-reflection of what do we mean when we say science is self-correcting? Where are these self-correcting mechanisms? And when I looked in the literature and philosophy of science and so on, there was a lot of hand-waving. There was appeal to journal peer review. I didn't believe in that anymore, having been on the inside and seeing that, if anything, the most selective, most prestigious journals published the least replicable findings. So I started to wonder what could we point to? Because I do think science is trustworthy. I do think most sciences get it right, and that in the long run, we are able to self-correct, but it's not that simple. And I think it takes effort and commitment. And so thinking about, where does the trustworthiness of science come from? There's some evidence in public opinion that's consistent with, I think, a lot of the thinking these days in philosophy of science, which is that while public trust in science has been high, I haven't looked at the numbers recently. I'm a little bit scared to look. I used to say up until a couple of years ago that even with COVID and stuff, actually public trust in science remained high globally. I think maybe now that's changing. As a US citizen, I'm especially concerned. But so the green bars show in the US, public trust in science was high, stayed high, higher than for almost any other institution. This is true around the world in many, many countries. But those same survey data actually show that the public is not naive. So they do trust science. But when you ask them, do you think that scientists admit and take responsibility for their mistakes? No. So the green dots are the proportion of respondents who agree that scientists admit and take responsibility for their mistakes across different kinds of science, and it's low. Most respondents in the US say, no, that's not why we trust science. It's not because scientists are transparent about conflicts of interest or admit and take responsibility for mistakes, which is good because that's not why science is trustworthy. Scientists are not superhuman. They're not noble. If we know anything about human psychology, humans are bad at admitting and taking responsibility for mistakes. That is not a quality of humans, and scientists are human. So the scientific institutions should be built on the assumption that scientists are not good at this. And if anything makes science trustworthy, it's not the individual moral characteristics of scientists. And so this is consistent, as I said, like a lot of philosophy of science these days is emphasizing the social nature of scientific knowledge. And this was echoed actually by a methodologist in psychology from the 1980s, Don Campbell, who back then wrote, the dependability of scientific reports comes from a social process rather than from dependence upon the honesty and competence of any single experimenter. Organized distrust produces trustworthy reports. So organized distrust is an appeal to Mertonian norms about science. We sometimes called it organized skepticism. And so the idea is that none of us are individually trustworthy. It's because we check each other and because we have formal systems where we check each other that we're trustworthy. So it's organized skepticism or organized distrust that leads to self-correction. And we have to have like formal infrastructure in place for organized distrust. It doesn't just happen magically. So when we say science is self-correcting, we have to be able to point to things. What are we doing to check each other? What are we doing to ensure that we're not relying on the trustworthiness of individual scientists? As I mentioned, I couldn't find a lot of answers to what these concrete self-correcting mechanisms look like in the literature. There was a book by Naomi Oreskes, who I think very highly of. I like a lot of her work. She wrote a book called Why Trust Science, and I found it lacking in this kind of concrete answer to where the trustworthiness of science comes from. So her answer was, how do we know that science has self-correcting mechanisms? Well, we know the same way we know other empirical facts, through observation. And she said, when we observe scientists, we find that they have developed a variety of practices for vetting knowledge, for identifying problems and attempting to correct them. It's all very vague. There's a little bit of discussion of journal peer review and grant peer review, but not much. In contrast, when you talk to people who actually try to correct science, who find errors in published work and contact journals and try to get papers retracted and so on, you get a very different story. So James Heathers is one such person who does a lot of kind of whistleblowing and scientific correction. And he wrote, in reality, mechanisms to correct bad science are slow, unreliably enforced, capricious, run with only the barest nod towards formal policy, confer almost no reward, and sometimes punitive elements for a complainant who might use them. And again, having now been on the other side of it, I'm now editor-in-chief of a journal where we've had a number of retractions, a number of, some of the very high-profile problems in our published work. And I completely agree with the whistleblowers. It's really, really hard to get something retracted. Even when the editor-in-chief wants to get it retracted, it's very, very hard to get it retracted. Even when we know absolutely for sure that there's fraud or false data, et cetera. So some people, try to say, okay, well, the way we know that science is self-correcting is the replication crisis. Look, that is scientific self-correction. Like, we deserve an award for the fact that we had this crisis. That's the sign that science is self-correcting. That's a terrible answer. And as someone who lived through the replication crisis, I want to say that is not how we want science to work, right? Things got way too bad. It should not take that big of a crisis for science to self-correct. It's also the very same people that are saying, oh no, everything's fine because, look, we're correcting now, are the same people, the most powerful people in the field, very often, who were trying to silence the self-correction, who were trying to say, let's not air our dirty laundry, don't do replications. Replications are for people who don't know how to do original research, et cetera. So in psychology, Fisk, Schachter, and Taylor are really, really big names. They wrote a chapter in the Annual Review of Psychology, one of the most prestigious periodicals, during the height of the replication crisis. And they said, all this is normal science, not crisis. A replication failure is not a scientific problem. It's an opportunity to find limiting conditions and contextual effects. Of course, studies don't always replicate. This is completely true. We shouldn't expect everything to replicate, and some failures to replicate are opportunities to find boundary conditions. That's not what the replication crisis was. That's what would be happening if 20% of studies were failing to replicate, and they were the ones that we were most unsure of and that were published as like big if true but not definitive studies. That would be a well-calibrated system. What was happening in the replication crisis was studies with thousands of citations that had been conceptually replicated dozens of times, that whole theories and careers were built on, and awards and everything, where the foundation of it was crumbling. Like, the individual studies that everything was built on were not replicable when tested more thoroughly with a direct replication. So similarly, I was on a National Academy of Sciences study committee in the US on replicability and reproducibility in science. And we were tasked with writing a report for the US government about the state of replicability and reproducibility in science. And we had an early chapter where we wanted to kind of set the stage for the public to understand that errors are normal in science, which of course is also true and is really important for the public to understand. And so the report ended up saying this in one of the early chapters: the advent of new scientific knowledge that displaces or reframes previous knowledge should not be interpreted as weakness in science. Again, I completely agree. In a healthy scientific discipline or system, this would be true still, right? There would be errors and they should not be concerning. The problem is this, to me, reads like asking for a blank check from the public to say we can make any error as many times as we want over and over again, even if it's an unforced error, and that's normal, right? So we can't ask for that. We have to be accountable for what kinds of errors are normal errors in science, and what does it look like when a scientific field should actually be losing public trust and needs to correct itself. So again, the same people who were saying all this is normal science in psychology in the early days of the replication crisis were calling the replicators and people pointing out errors names like replication bullies, human scum, methodological terrorists, second stringers, destructive iconoclasts, and my favorite one, accuracy fetishists. That one I'll happily own. And yeah, so it's, I think, a little bit insincere to then say the reason with science is self-correcting, the reason we don't need to worry is because all those replications are happening and this reform is happening, because these people were not a fan of those replications. So it reminds me a little bit of this cartoon. I felt in the kind of peak of the replication crisis in psychology, it felt like we were here. We don't often see the rest of the cartoon, but I think it's important to pay attention to what happens later on in this cartoon. So I think that psychology is facing a situation where if we want to remain trustworthy and enjoy public trust, we need to be thinking about how to earn that trust, how to regain our credibility. And I think we can be a leader here, and we have been in many ways. And I think it's a situation that other disciplines are going to and are already starting to find themselves in. And they can learn from some of the things we've done well and some of the things we've done badly. And I think, again, the key here is going to be organized skepticism that can lead to self-correction. And so specifically, I think in order to have self-correction in science, you need two fundamental things. The first thing you need is transparency, so that errors can be detected in the first place. If researchers don't have to disclose very much about what they did, they just say, take my word for it. It's very hard to see if we have problems. And then the second is this idea of organized skepticism, organized distrust, because we can't stop just at transparency. The analogy I use is the analogy of, like, if you want to evaluate how good a car is, if you're thinking of buying it, you need transparency. So of course the seller should be expected to lift the hood and show you what's under the hood. But it's not enough that in principle you could look. You actually need mechanics to go in and stress test it and tell you if it's in good shape, right? So in psychology, the reform movement in the wake of the replication crisis has focused a lot on transparency. And we've moved the needle a bit, and I'll show you a little bit of evidence on that. We still have a long way to go. But actually, that's not the end goal, right? Getting researchers to be more transparent is just the first step. And what we then need to do is incentivize and reward researchers to go in and use that transparency to stress test the research, find errors, see how we're doing. So I'll talk a little bit about both of these today. And I'm going to say in transparency, we're making progress. I think we still have a lot of work to do. And this thumbs up might seem overly optimistic when you see the data I'm about to show you, but relative to where we were 15 years ago, it's much, much better. So the first, I'm going to show you some more data from Tom Hardwick, the same meta researcher I mentioned before, looking at just two time periods. So one kind of in the middle of the replication crisis in psychology, 2014 to 17, and then one more recent, 2022. And looking at the proportion of psychology articles that are transparent in different ways. So the first one is the proportion that share original data. So in 2014 to 2017, it was 1.6% of articles sampled randomly from all psychology journals shared data with the article. Like, you could find a link to the data in the article. And then in 2022, we assessed two different samples, another random sample of the whole field, that's the middle data point, and then a sample of high impact journals. And we find that it's an order of magnitude higher by 2022. So still very low in absolute terms, still only 15% of articles are associated with the data set, public data set, but much, much higher than 2014 to 17. What about analysis scripts? They're less common than original data, but again, jumping from basically non-existent in 2014 to 17 to 1 in 10 or so articles now, or recently sharing analysis scripts. Sharing materials. So in psychology, this usually means like questionnaire data or the script that the experimenter reads to the participant or something like that. A little bit more common than the other two. And pre-registration, which, as I mentioned, is writing down your plan for data collection analysis in a time-stamped repository, similar to like clinical trial registration, but a little different. But yeah, same idea. So again, like in absolute terms, these levels are still low, but the change from before the replication crisis is dramatic. I mean, it was basically nobody did it before the replication crisis, and now it's starting to become. The perception in the field, interestingly, is that all journals require it, and it's suffocatingly bureaucratic requirements. But when you look at the actual data, no, it's very easy to find a journal that will let you publish your research without sharing your data. But there's more and more infrastructure, activism, kind of social movements, training available. So these are different organizations and tools and kind of collectives, communities that try to increase awareness and ease of transparency. So things that help researchers learn how to post their data responsibly or how to pre-register, or these journal clubs where students get together and read about open science and transparency and so on. So there's a lot of infrastructure. And Brian Nosek, who's the director of the Center for Open Science and one of the leaders of this movement in psychology, he's a social psychologist by training. He has this nice pyramid where he talks about culture change in science, and he talks about how you have to go from making something possible to then making it easy, making it normative, rewarding, and required. And I would say for transparency, things like sharing data and so on, we've moved up this pyramid to where there's now a lot of tools, a lot of training available. Anyone who wants to do it can do it, probably for free with some effort, but not an impossible amount of effort. We're moving up to making it rewarding, and now a few journals, including the one that I'm editor of, is now making it required. But we're not quite there yet as a field. So Tom Hardwick is the senior editor for a new, so the journal that I'm editor-in-chief of, Psychological Science, we started a new branch of the editor team called the Statistics, Transparency, and Rigor Editors, STAR Editors. And Tom Hardwick is the head of those editors, a senior STAR editor. And together we wrote an editorial when we started our term, where we announced that we were now going to make transparency required, with exceptions when that's what's ethically responsible. So we don't require authors to share data when that would compromise the interests of participants or things like that. So we require data and analysis scripts, materials, and we do a computational reproducibility check of every article before we publish it. That's turning out to be a lot more challenging than we expected, because researchers in psychology are not used to sharing their analysis scripts, so they're really hard to understand, et cetera. But okay, so that's transparency. But I think it's really important to remember that transparency is just the beginning, and it doesn't guarantee that science will be self-correcting. You can have all the transparent stuff out there, but it could just sit there with a bunch of errors, right? And Andrew Gelman, the political scientist, has a nice, very short paper called Honesty and Transparency Are Not Enough, where he makes this point. He says, consider the consequences for a researcher who eagerly accepts the message of ethical and practical values of sharing and openness, but does not learn about the importance of data quality. They could then just be driving very carefully into a brick wall, conducting transparent experiment after transparent experiment, and continuing to produce and publish noise. Right, so transparency in principle makes self-correction possible, makes it possible that we'll do more rigorous research, more replicable research, but it doesn't have to at all. Like, transparency just means that there's the possibility that our errors will get caught, but they won't necessarily. So that's what we need organized skepticism for. And I think that here we're very far from having the kinds of self-correcting mechanisms that we need. And part of the reason this was always going to be harder. So transparency felt at times like the open science movement in psychology felt at times like we were like dragging people towards open science with a lot of resistance. Organized skepticism can be much harder for people to accept. As hard as it was to get people to be transparent, the idea that then other people are going to go in and check your work, and that's why we were asking you to be transparent, is going to be harder for people to swallow. And another reason why it's going to be hard is that you have to find the people to do that checking. And as Kurt Vonnegut said, another flaw in the human character is that everybody wants to build and nobody wants to do maintenance. Hopefully, talking to statisticians, that vibe is a little bit less strong in a group that focuses on methods and rigor and so on. And we have that stream within psychology. We have people who go into psychology because they care a lot about statistical rigor and other kinds of rigor. So luckily, it's not everybody that doesn't want to do maintenance. There are people for whom the idea of like bolstering our literature, making everyone else's work better, is a valuable and meaningful thing, but we need to reward it as a field. Or as James Heathers, the whistleblower that I mentioned before, who does a lot of pointing out errors in science, he put in a tweet, "Science is self-correcting, sure, when we correct it, not because of magical progress." So there are many of us who would stand up in front of the public or in front of students and say science is self-correcting and psychology is self-correcting. And then with the replication crisis, we had to ask ourselves, like, wait, are we doing the work, and are we rewarding the people who are doing the work? So if we go back to this metaphor where transparency is lifting the hood, we have to ask, like, are we investing in mechanics, in people who have the right expertise, who can go in and stress test other people's work? And are we thanking them when they do that, or are we punishing them? And the reason this is important is also, I'm going to rely very heavily on Tom Hardwick's work here. Here's another paper by Tom Hardwick, where he looked at both transparency and then kind of accuracy in some papers, looking at a journal where they implemented this data sharing requirement. So this is just looking at whether the paper has a data availability statement from before the open data policy went into effect till after. And as you can see, the proportion of articles with the data availability statement went up quite a bit after, not to 100%, but quite high. But then he also looked at whether an independent researcher could actually reuse these data sets. So like, could you download it and make sense of it and so on? Before the policy, about 22% of papers had a data set where Tom and his colleagues evaluated that you could actually reuse the data set. Afterwards, it was 63%. So much, much better, but still far from 100%. So again, transparency is not enough. Just because people post their data doesn't mean that we could actually go in and find errors or do some generalizability tests or multiverse analyses or things like that. So there's a lot of work to do if we want things to not just be transparent, but actually usable for skepticism and correction. So partly because of my experiences.
I just wanted to let you know that the name part, I'll assume it's walking.
Oh, I'll move it. Yeah. Do this. Yeah. Okay, so my experience as a journal editor made me quite cynical about the role of journals in all of this and how we're contributing to these problems. And one of my experiences was that it wasn't just, the drive for high impact articles or things like that, but actually quite explicit status bias. So when I became editor-in-chief of a social and personality psych journal, I instituted this practice, not even a policy, but just literally a practice that I would engage in, where when I would evaluate a manuscript for desk rejection, decide whether or not to send it out for external review, I would blind myself to who the authors were. I would literally hold up my hand on the PDF so that I wouldn't see their names or institutions, and make my desk rejection decision without knowing who the authors were. And I thought I did this because we have double-blind review in many psychology journals where the reviewers don't know who the authors are, but the editors do. And a lot of manuscripts are desk rejected. So a lot of the decisions are happening just with the editor. And the same principles should hold there, that it shouldn't matter who the authors are. I should be able to evaluate the research on its own merits. So I was doing that, ended up desk rejecting some famous people, got people angry, and the board of the journal, the publication committee that hired me, got very upset with me and explicitly told me in writing in an email that I was stepping on important people's toes, that this was not okay. And when I would ask, well, what's wrong with my desk rejection decisions? They would say, well, important people are upset. That's what's wrong. And at one point, they forwarded me an email from an award-winning social psychologist that said, Samin desk rejected my manuscript. I found this incredibly distasteful and I won't submit to the journal again. And I said, okay, let's look at the manuscript and let's look at my decision letter and we can discuss that. No, that was not the point. The point was that an award-winning person was upset. So I ended up writing about this experience and other feelings I had about journals for Wired, where I said, I think it's reasonable to expect scientific journals to do some basic quality control, to not use who the authors are, what institution they're at as a basis for accept or reject decisions, to not try to maximize their impact factor by publishing the sexiest findings and so on. And many, many journals aren't doing this and are even explicitly, or at least quietly, sometimes not explicitly, doing this. And I think that contributed a lot to the replication crisis. And it also contributed to other problems like misconduct and retractions. So in psychology, actually in marketing, but an adjacent discipline to psychology where they publish a lot in psychology journals, was a big case you might have heard of. Francesca Gino was recently not quite fired, but Harvard put her on leave, unpaid leave, after accusations of fabrication. They did an investigation and found evidence of fabrication in her papers. 4 of her papers have been retracted. 2 of them are in the journal that I'm editor-in-chief of. And then she turned around and sued the whistleblowers as well as Harvard. And there was a lot of concern that this lawsuit, $25 million lawsuit against 3 researchers who they first alerted Harvard to their concerns. Harvard did the investigation. When Harvard found her to have committed misconduct, then they posted their evidence that they had shared with Harvard on their blog. So she sued them. And yeah, that definitely had a chilling effect. Like there were already very, very few people who were willing to call out bad research in psychology. And then this $25 million lawsuit happened, and now there's going to be even fewer. Luckily, the lawsuit was dismissed. So the judge, there was a motion to dismiss and the judge dismissed the lawsuit. And what I thought was really interesting in that lawsuit was the judge cited a previous decision in another case because there was some concern that, what the motion to dismiss would depend on whether or not Francesca Gino was considered a public figure. If she was a public figure, then defamation is irrelevant. You can criticize a public figure and they can't bring a defamation lawsuit against you. What was interesting to me is the judge said not only is Francesca Gino a public figure, which of course she is because she gives tons of public talks and TED Talks and things like that, but actually the judge cited a previous judgment that said that basically as soon as you publish scientific research, you are by definition a public figure. So this was another case where the person suing was named Dilworth. Dilworth is an obscure engineer. But anyone who publishes becomes a public figure in the world bounded by the readership of the literature to which he has contributed. By publishing your views, you invite public criticism and rebuttal. You enter voluntarily into one of the submarkets of ideas and opinions and consent, therefore, to the rough competition of the marketplace. I think this is important for scientists to remember that when we publish, we are open to criticism, just as we are open to praise, right? We take all the praise and all the public attention. Psychologists get a lot of media attention. It's not hard for us to get TED Talks, to get book deals, to get invited to give fancy talks at Google and things like that. And with that comes the negative attention too, and it should, right? If we say something that's miscalibrated or inaccurate, we should get called out. But it's really, really hard to do that. What we have now, I would argue, is not organized skepticism, but disorganized skepticism. We have a few brave people that are willing to call out bad research, and when they do, they get called names or sued. So we're like, not even really at this level of make it possible yet. So that's one of the reasons that we created this team of star editors at Psych Science, was to institutionalize some self-correction, some criticism, and so on. This is pre-publication in our case because we're vetting things before we publish them. And these are the team of star editors that we have now. This doesn't mean much to you, but to a psychology audience, they would recognize that many of these people are the very whistleblowers. So the people that called out the Gino fraud that led to retractions in our journal. When you have critics like that of your journal, you want to bring them on your team, right? Those are the kinds of people you should want on the inside, helping you identify those papers before you publish them. Other people who've done meta research showing that our journal is not doing a great job with like data sharing or transparency or things like that, we brought them in, and they're helping now create policy for the journal and improve our practices. We've also partnered with this group called the Institute for Replication, which was started by economists, where they do systematic, mostly reproducibility checks of published papers, mostly in econ and political science, but now they're doing 2 in psychology, ours and another one. So I think we need to really be thinking about how we can encourage more organized skepticism. I think that's really the main answer to the replication crisis in psychology. And I think what other fields should be thinking about is what would they point to if you asked, where's the self-correction? What are you doing to encourage people to find errors, to correct them? Are you rewarding the people who are doing that? So we need more skepticism, and it needs to be more organized, not just individual brave people who are willing to go against the norm, but creating positions, creating rewards, incentives for people who do that. And another really important point is, and this is one that philosophers of science who emphasize the social nature of scientific knowledge emphasize too, Helen Longino is most strongly associated with this idea, is that when we're relying on this social process of checking each other to get closer and closer to truth, it becomes even more important that we have different biases and different perspectives. So the diversity of the scientific community becomes really, really important because we're counting on that diversity to out each other's blind spots. So this is Naomi Oreskes summarizing Helen Longino's view. The greater the diversity of a community, the greater the degree of objectivity it may be able to achieve as individual biases and background assumptions are outed. So if you imagine, peer reviewers of a manuscript, if they all have the same assumptions, biases, and blind spots, then they're not going to find errors. You want reviewers coming from different perspectives with different blind spots. Okay, I think that's everything I have. Thank you.
Any question from the audience? Any
I was wondering if there's been any discourse on whether alpha equals 0.05 has been a bit too high.
Yeah.
Now it's a bit much more margin for biases and rejecting more.
Yeah, so the question is, has there been any discussion in psychology on whether alpha of 0.05 is too high? So there was a paper called Redefine Statistical Significance that you might have heard of by Benjamin et al. I was one of the 70 co-authors on that paper. It's extremely unpopular. So we argued in that paper that for non-pre-registered work, for work where you can't show that you followed the rules of NHST, that you had a plan ahead of time, 0.25 is way too loose, given how much even a little bit of flexibility inflates type 1 error rate. So we argue that the alpha should be 0.005 unless you pre-registered everything and followed your pre-registration. And that we're basically arguing for 3 categories. Instead of 2, significant, not significant, we said significant below 0.005, then between 0.005 and 0.05, we'll call that suggestive, and then above 0.05, not significant. I think it's my most unpopular paper. Like everybody hates it. And so it's really interesting. When I became editor-in-chief of Psych Science, like I kind of wanted to make that policy. Like I'm not saying we won't publish stuff within the intermediate range, but just don't call it like definitive. Let's use more cautious language around stuff that's in that range. And I didn't even dare try, because even my own team of editors who are on board with almost everything else we're doing, I knew they would rebel if we tried to implement that. But honestly, de facto, that's what we're doing. When we get manuscripts, if there's a study that's not pre-registered, there's obvious signs of flexibility, and the p-value is 0.02, 0.03, I'm not convinced. I want to say, well, replicate it or do a pre-registered version of this study, or present it as interesting, but big if true kind of thing. If it's too hard to collect more data, that's fine, but don't try to tell me that you definitely have an effect there. So it's an ongoing conversation. I would say the field is not going to abandon 0.05 anytime soon, but it leads to this kind of hidden curriculum where not everyone, many of us are skeptical of high p-values, but it's like not okay to say so out loud. So this weird like double standard. I think maybe I still am somewhat hopeful that at least our intuitions will shift to like p-values between 0.01 and 0.05 are like, okay, give me more evidence. And I think the introduction of more Bayesian statistics helps, because if you convert the p-value in that range to a Bayes factor with an uninformative prior, my understanding is that it's like weak evidence, basically.
Yeah.
Thank you. My name is Anna from the Burnett Institute. I'm with Southern River. I was interested in your discussion about reward.
Mm-hmm.
Do you know what's effective rewards if we started rewarding people for either transparency or lack of skepticism? Do we know what people are going to respond to as a reward?
Yeah.
That's quite a broad term, right?
So empirically, I don't think we know very much. My intuition is that depending on the discipline, some combination of journal publication and grants, right? So in psychology, I would say publication in prestigious journals is more important than grants. I think in biomedicine, it might be the opposite. But prestigious journals have a lot of power over incentives, partly because even if it's grants that matter, one way to get grants is to publish in high impact journals, right? So to my mind, journals are the key lever that controls the most important incentives, because they're how we count the currency of like status in most sciences. How much have you published in high impact journals? And so for example, that's one of the reasons we wanted to require transparency at Psych Science. So we have an acceptance rate of about 7%, one of the more selective journals, one of the more prestigious journals in psychology. If we require it, people will probably do it. Like if it was a less selective journal, less prestigious journal, they might just choose not to submit there. That's not really an option with our journal. If you want a career in psychology, it's one of the few journals that will really matter for getting a job or getting grants or things like that. So I think getting into those positions and then shifting the incentives in those roles. That's, I guess, maybe an obvious answer, like money and publication are the things that we can use, but we should be using those more than I think we are. Yeah.
I think it's actually also important that we have a bunch of people who just focus on doing the main things, but I can imagine that it's really hard to incentivize them, because generally, as you said, like maintenance is considered as less impressive than building something new, right?
Yeah.
So how do we actually have a way to reward these maintenance people?
Yeah, so one path towards that some people in the open science and reform movement are working on is a contributorship model instead of an authorship model of credit. So in psychology, and medicine too, the official norms and rules for authorship are that you can only get authorship if you contributed to the writing of the paper. Like that makes sense. It's authorship. A lot of times researchers ignore those rules and still include as authors people who do more technical work, but sometimes they don't. Sometimes those people get an acknowledgement or nothing. And so the move towards contributorship is saying, first of all, let's rewrite the rules that you get to be a contributor, what is traditionally called an author, if you do other important things besides the writing. So a statistician who doesn't contribute to the writing, but contributes to the analysis plan or even the design of the study and so on, should get an authorship level role. So that's one aspect of contributorship, is redefining what it means to contribute. And another is to name the contribution of different people on a project so that it becomes easier in like promotion and hiring and so on to know who did what and to reward people for that. I think we need to think even bigger than that. That's a step, but it will actually make things worse if people only value the kinds of contributions that they think of as, you know, the original contribution, whatever, not the maintenance stuff. So we really need to be thinking about contribution at the group level rather than the individual level. So there's too much of a star model in academia, I think. We want to reward individuals and their superstars and stuff like that, ignoring the fact that the only way they can do that is because they have a team. And in evolutionary biology, there's some pretty good models showing that if you reward based on individual performance, when really the outcome that's relevant is the group performance, is science producing knowledge, is the group producing knowledge, you're going to get terrible outcomes. So like, I don't know, I'm like talking way outside my area of expertise here, but a classic example is chicken coops. Like if you reward chickens who lay the most eggs, they're actually the ones that are like attacking other chickens and killing them and things like that. So you actually get a lot lower egg production for the whole coop if you select on individual outputs. In sports, like in team sports, there's the idea of value over replacement player. So the way you should evaluate whether a team member is a good contributor is not how many points they score, but how many points a team scores when they're on the field or something like that. And I think we need the same in science. We need this idea of value over replacement player, that if you have a member of your team, your department, whatever, that is making everyone else's work better, but they're not the star. They're never the one getting the grant as CI or whatever. But you can tell that when they're in the group performs much better. You really want to keep those people on your team. So we need metrics that measure that. And if baseball can figure it out, then I think scientists should be able to figure it out as well. The other nice thing about value over replacement player that I like is that it should, in principle, also capture bad behavior. So people who make their whole department worse because they bully people or they encourage cheating or cutting corners or things like that. You know, we all know those colleagues who are creating a bad atmosphere, either in terms of research practices or interpersonally or whatever. They're going to drag the team down, and that should be measurable also in these metrics. So I think the star culture of science makes it really, really hard to reward and value the maintenance type people. But actually, if we had a value over replacement player or a group performance metric, those people, the value that they're bringing would be more visible. Yeah.
So thanks for a great talk. You focused on the social sciences,
Yep.
Naturally enough. But I'm just wondering if you have anything to say about other sciences, in particular, in interesting cases, the sort of scientific studies related to the pharmaceutical industry, because of the big financial incentives. And where I have a role where I think if you want some really spectacular examples of bad science is forensic science, where there are kind of similar incentives, that there is a whole profession that wants scientific evidence to prove that this method is reliable in court. But the outcomes are just court judgments, which are often bad. And you know, the result is disastrous. But anyway, I was interested in your view about the pharmaceutical industry as well. And because they have the strong incentives, but also arguably some pretty strong regulation and safeguards. And I don't know where the balance ends up, do you think?
Yeah. So my opinion would not be worth more than anyone else's, but I'm happy to share it. So yeah, I've been thinking about like, what are the risk factors? Like, I think there's some that psychology is really at risk. So the fact that we get a lot of popular attention, that if we have an answer to like how to improve your romantic relationship or whatever, people will eat it up. So we can skip a lot of steps. People won't scrutinize whether we really have good evidence for what we're saying. We can sell our answers directly to the public and get rich and famous that way. So that's less true in many other disciplines. But then there's other risk factors that we don't have as much. For example, so in pharmaceutical and biomedical research, I think the amount of grant money at stake and also how much people's salaries and ability to do their work is tied to grant money. In psychology, we do a lot of cheap research, and if the grants dried up, we don't lose our jobs. We're not on soft money, and we can even keep doing research really without grants. A lot of our research is quite cheap. So even though we do depend on grants a bit, it's much, much worse. And in pharmaceuticals, yeah, there was a guy who was being interviewed on radio who was a critic of a lot of biomedical research, and he joked that he wore bulletproof vests to conferences because he was so unpopular. I think it was Vinay Prasad. So I think the stakes are much, much, much higher in pharmaceutical research and in biomedical research in general. So my impression is that there has been a kind of critic movement in biomedicine for longer than there has been in psychology, but it's gotten less traction. And I think it's because there's much more powerful forces against it. In psychology, there were famous people who tried to shut us up, but they didn't have millions of dollars backing them. They just had prestige. And so eventually, thanks to social media largely, actually, we could get traction because we had arguments that won. My impression is in biomedicine, it's not enough to have winning arguments. There's so many powerful interests against, critics. But then on the other hand, there's more of a rubber meets the road in pharmaceuticals than there is in social psychology. So in social psychology, if we're claiming do this and your romantic relationship will be better, we'll never get found out if we're wrong. Like there's not a really clear cut, like no bridge falls down. So like in engineering, that's the clearest example of the opposite extreme, where if they say this will work and it doesn't work, everybody sees the result. My guess is pharmaceuticals are somewhere in between, right? And it kind of depends on what kind of claim they're making. If they're saying this drug will help your hair grow back, people can see whether or not that happens. There's noise for sure, so that there's more noise than in engineering. So, but in social psych, there's so much noise that it's really, really hard to tell when there's a signal or not. My guess is pharmaceuticals is somewhere in between, and that some claims are more like social science claims and some claims are more like physical science or engineering claims. Forensic science, from the little bit that I know of, it sounds like maybe one of the few fields that's worse than psychology. It sounds quite rough, but there is a little bit of a movement for this kind of reform in forensic science. Yeah. And I mean, the experience with psychology, there have been movements like this in psychology every few decades, and they often didn't get traction. So in the 90s, there was a very strong movement to try to move away from NHST, didn't get traction. A few journals banned p-values, but then they stopped. And so then this time it worked. I mean, it didn't work so much for moving away from NHST, but it worked for at least like what we're doing is bad and we need to change something. And it's really unclear when it works. So I think even if it's a small movement, there's always a chance that it'll catch on and the right people will get in the right positions and be listened to. No, I think it's good to keep that movement alive, even if it doesn't seem to be growing.